In this, we are going to review how to write YP. YP means the particular solution for undetermined coefficient method problems. So if you have a problem like that that has like several steps, like main like 4 steps, and in a special case there are 5 steps, and we're going to go all those steps. So just to look at the basic theory. So let's say we have a differential equation which is a y double prime plus by prime plus cy equals some term on the other side. Um, so if you have a problem like that, the first step is write the characteristic equation. So it's a characteristic equation. We normally write using lambda. We write the characteristic equation. So what happened? The derivative becomes lambda powers. So it will be clear when you look at problems. And the second step is we try to find the zeros of the characteristic equation. So we have a characteristic equation and we're going to find the zeros of that. So that's the second step. And after you find the zeros, what we're going to do next is we can write the YC. So what is YC? YC means the complementary solution. So complementary solution means um, the solution of the homogeneous equation. So we just said the left hand side equals 0 and try to find the solution of that. We normally call that solution is YC, the complementary solution. The fourth step, we're gonna guess. We're gonna write YP. So we can only do 3 types using this technique. So the first type is the fx can be a exponential function. That's the first type. The second type is fx can be sine or cosine, like something like 4 sine 2x minus cosine 5x. Yeah, something like that. And the third one is the polynomial type. So it can be a polynomial. So those are the only 3 types that you can solve using the undetermined coefficient method. So, and then that's a very special case also. Sometimes what happen, fx also is a part of yc. So you can see some yc terms can be appear in fx. So if that is the case, the things can be a little bit difficult. So in this case, what you have to do is you have to multiply by an extra x. So we assume x is the independent variable. So what we do, we're going to multiply by an extra x term just to get a linearly independent term. So why we do that? To get a linearly independent term. So when you, otherwise, what will happen when you try to plug in yp, the left hand side going to be 0 and the right hand side is not equal to 0, create a contradiction. Just to avoid that, we can multiply by extra x. It will be very clear when you look at problems. So we can solve like about 12 problems here quickly. Okay, so and then we also need to know how to write the particular form. So we have something special, like for example, if you have fx and these are corresponding yp. The first type, if you have e to the alpha is just a number. So if you have e to the alpha x, your yp is going to be a e alpha x. So you just add extra a in front. So that's the form of yp. The second type has 3 types. Like it can be cosine beta x, or it can be sine beta x, or it can be a combination of sine cosine. Only thing here is this should match to match. So all 3 types only have one. So all of them just has one form. So what's the one form? It always should have both of these. The reason is when you take the derivative, cosine becomes sine and sine becomes cosine. Because of that, in the general form of yp, we add both of them. Maybe some of them are 0, but we still don't know. So since we don't know, we just write a b both. We write sine and cosine both. And the third type is a polynomial. If a polynomial on this side, maybe some of the terms are missing, but still when you write the yp, you have to write all the terms, because when you take the derivative, those powers gonna reduce. So because of that, since we don't know, we write everything. So it's all the terms. So those are like kind of basic theories. So let's try to look at a few problems now. So what we're trying to do, this is a problem. So write the form of yp with least number of unknowns. So that's very important. Least number of unknowns. Because you can write this one with so many unknowns, and then it will be a very difficult problem, because when you have so many unknowns, you have to find them. So that's the problem. So what we need to do is we need to write it with least number of unknowns. So let's see how we can do problems like that. And if you are not, because normally like when you do a problem, you can see in the third step you have to find the yc. the complementary solution. That means complementary solution coming from undetermined coefficient technique, from the constant coefficient differential equation normally for these undergraduate level classes. So if you are not familiar with that, please look at that first, and you can see there's a practice problem session for that also with 12 practice problems. So you can watch that first before you try to do that. Need to be very clear what we're trying to do here. Okay, so let's go problem by problem. So let's start with something easy. So let's say we have y double prime minus y prime minus 6y equal 5e2x. So this is like a general problem. So if you get a problem like that, it is always what we're gonna do is we're gonna look at the form of yc first. It's always a good idea because we really don't know whether this number appear again. So because of that, so we can look at the yc. So let's see. So we got the characteristic equation. So which is we're gonna how to write it? The derivative is going to be lambda powers. So that means it's going to be lambda squared from the first term minus lambda 1, we don't write 1, and then there's no derivative, so it's just going to be negative 6. And then what we do, we can factor this. So it's just a quadratic equation, so you can factor always. So lambda minus 3 and then lambda plus 2. So those are two terms. And then we set this equal to 0 as a characteristic equation. When you set it, and you can see the first one going to give you lambda equal 3. That's the first solution. The second one is going to give you lambda equal negative 2. That's the second solution. So that means the yc is simply c1 e to the negative 2x. We know write the first small one first, and then c2 e to the 3x. So we assume x is the independent variable. If the t is the independent, this will be in terms of t. We do that later, those conversions. Now you can see this 2 is not equal to any of those numbers. So that means this is an easy case. So that means in this case, you can simply write yp. There are no repetition of that. So we just say a e to the 2x. So that is the form of yp in this case, because these numbers are not appear. So you can see that's how we write it. So it doesn't take much time if you do it this way. So let's look at the next problem. And what we do in next one, we're going to match this number and see what happens. So let's do the next one. So we have y double prime minus y prime minus 6. So we did not change the differential equation, the homogeneous part. We just leave it like that, just to save time. On the other side, you can see now it's not 2, it is 3 now. So you will see there's a problem now, because we know the yc, it is from the previous problem, c1 e to the negative 2x, and then c2 equal e to the 3x. So you see that now these two numbers match. Since these two numbers match, you cannot use this term in yp directly like that, because if you try to use that, once you plug in it, the homogeneous part going to give you 0. The right hand side, the left side going to give you 0. The right hand side is not equal to 0. So it's a contradiction. That's not possible. 0 cannot be equal to something non-zero. So so there's an issue. 0 can be equal to non-zero. So because of that, we cannot use that directly. So what we can do in this case, we can just multiply. That is step 5. Remember in the basic theory, this is step 5. We just multiply by a extra x. That's how we do. Multiply extra x. So that means your yp is going to be, so we normally do the a e 3x, but we multiply by an extra x. That's how we do. Or if you write it properly, you can write this one as ax e to the 3x. So that is the correct form of yp for this problem. Let's look at the next one. So we have the same differential equation, but on the other side we have 2 sine 3x minus cosine 2x. So this is a sine cosine problem. So when you have sine cosine problems, and you know that you have to write both of them, but also you see that the first one has a 3x, the second has a 2x. So that means you're going to get 4 terms. For the first one you get 2 terms, for the second one you get 2 terms, you get 4 terms. And also you see that these 3 match with you can see yc. If you look at the yc, it's the same yc for this problem as well. So you can see it is negative 2x plus C2 is 3x. So it's a 3 match. But this is different. There's no match here because you can see to get the sine cosine terms, we know that the lambda has to be complex. So that means here actual lambda is, because there's no e term, is 0 plus or minus 3i. That's the actual lambda. So it is not 3, it is 3i, it's complex. So that means even though it looks like 3, it's not really 3, it's like it's coming from a complex lambda. So that means this is like a different lambda situation. So that means in this case is yp is just obtained using the normal criteria, which is a, because the sine 3x terms you get a cosine 3x plus b sine 3x because of the first term. From the second term you can get another 2, so this is c cosine 2x plus d sine 2x. So that is the correct forms. There are 4 terms here. From the first one you get 2, from the second one you get 2. Okay, so now let's look at this problem. So it will be very similar to this one, but you will see that you get a different answer. So the next one, so we have y double prime plus 9y equals 2 sine 3x minus cosine 2x. So you can see we change the differential equation this time, but the other side is still the same. Let's see what happened here. So if you look at the characteristic equation, you can see it is lambda squared plus 9 equals 0. So that's going to give you lambda squared equal negative 9. That means lambda, if you take the square root, it's a complex number, so it's going to be plus or minus 3i. That's what happened. Because what we normally do is we can write this one as 9i squared, because we know that I squared is negative 1. So because of that, we write it like that, and then take the square root, so plus or minus. And then, so this is simply equals to 0 plus or minus 3i. Because the 0, there's no exponential term. That's corresponds to the exponential term. So there's no exponential term. So you only get the sine cosine part. Okay. Because we normally call this alpha. Alpha equals 0, beta equals 3. So that's what we get. Okay. So because of that, and you can see your yc has this form now. So it is simply because of that, because there's no e term, there's no exponential term. So it's going to be simply c1 cosine 3x plus c2 sine 3x. Actually, we discussed these kind of problems in detail in the constant coefficient video, so you can see more like that. Okay, now you see the problem here. So you see that sine 3x is here. That means you cannot just use sine 3x as before in the previous problem. In the previous one we just use sine 3, but you cannot do that anymore. If you use that, again the left side going to give you 0. So just to avoid that, what we do, we're going to multiply by an extra x. That's it. So multiply by an extra x. So we're going to multiply by an extra x. So that means, what does that mean? That means your yp now looks like this. So from the first term, the 2 sine 3x term, you get a, you multiply by an extra x in front. So ax cosine 3x, and then bx sine 3x. So that is the first term because of the repetition. And the second term has no problem. So it's just going to be normal one. So it is c cosine 2x plus d sine 2x. So you see that only term is there's extra x here, there's extra x there because of this sine term repeat. Okay, so that's the solution for, that's the yp for part D. So let's look at the next one. So we have y double prime minus y prime minus 6y equal 3x e to the negative 3x. So when you have a problem like that, what we're going to do, we're going to separate, we can look at them separately and write the form for both and then multiply them together. So, and you can see as before, the yc is the same. So, and then you can see the yp, what we do, we write the separate form, and there are no repetition, and you can see those numbers are different, so it doesn't match with any of them. So this is an easy case. So from the first one, 3x going to give you ax plus b, and then so the exponential term has a c e negative 3x, but we really don't do that. We do not need this extra c. The reason is, if you have extra c, you can always multiply inside through. So that means the c is already a factor of factored into a and b. So because of that, we are not going to write extra c here. So just ignore c. That means we can write this one as ax plus b e to the negative 3x. So that is the best form with least number of unknown. So you only need 2 unknown for this problem. We don't need 3. Okay. So only 2 unknown. So only 2 unknown. So let's see what happened in this problem. So we have the same differential equation on the left side. On the right side, you see that you have 3x. So you see this number repeat. So that means we have that multiplied by extra x situation. So it's the same yc, and then you see that this 3x repeat. So because of that, you have to multiply by extra x when you write the exponential form for e. So that means your yp, so for 2x, it is simply going to be ax plus b, that's for the 2x term, and for the exponential term, you can see this is e to the 3x, so you have to multiply by extra x. So that means it's going to be x times e to the 3x. So we multiply by an extra x term here. Now what we do, we can multiply through, just multiply through, so you can write the final answer as a x squared plus bx times e to the 3x. So you can see there are only 2 unknown, a and b. So there's no extra one, only 2 unknown. Okay, so that is clear now. So let's look at the next one. So let's look at a little challenging one. Let's say we have y double prime minus 6y prime plus 9y equal x e 3x. So you see we have a different homogeneous part now. So if you look at the characteristic equation, so you can see it is lambda squared minus 6 lambda plus 9, and we know how to factor this one. So the factors are lambda minus 3 and lambda minus 3. So that means it is lambda minus 3 squared. So when you set it equal to 0, you can see that the lambda is going to be 3 and 3. So it's a repeat. So when you see the repeat, that's the situation we can add extra independent variable. So that means your yc now is c1 e to the 3x. Assume x is independent variable here, that we know. And then for the second term, we get c2x e to the 3x. So because we need extra x here. So now, and you see that term exactly appear, that's the exact same term here. So that means you cannot use x e to the 3x as part of the solution, because it's going to be 0. So what we do, we're going to multiply by an extra x here. So that means, so what happened when you write the solution, so your yp is now, you can see the exponential part, the polynomial part, that means the x term is just going to give you ax plus b. That part is clear. But if you look at the exponential part, it is going to be, so it cannot be e to the 3x because it's already there. It cannot be x e to the 3x because it's already there. So you have to go to the next one. That means it could be x squared. We will multiply by extra x. So that means it's going to be x squared e to the 3x. So that is the correct form, and we do not add a c here because a, b already has that. So that is the right form. So now what we can do, we're going to multiply them together. So the first one is for the x term, the second one is for the e to the 3x term. So if we multiply them together, you can see that it is going to be a x cubed now, because x squared, and plus b x squared, and then you get the e to the 3x term. So it's very clear now, because the reason is why we do that. You can see because e to the x is already there, xex is already there, so you can use those two because you know the linearly independent solution. So what we do, we can multiply by an extra x. That's why you multiply by x squared right now, and then after we do that, multiply through, and you get the answer like this. Okay, so let's look at the next one. So as the next one, we have y double prime minus y prime minus 6y. So that part is the same, in the same yc. And on the other side, we have 4x squared minus 1, 3 e to the 3x sine 2x. So we have three terms. So what we do, we write the three forms and multiply them together. That's how we do. So it doesn't matter how many terms we have, just do the same thing. So, and again, we have the same yc. And so let's start writing yp term by term. So yp. So from the first one, from the polynomial part, you get a x squared plus bx plus c. Even though you don't have an x term, you still need to write x term in this one, because when you take the derivative, power going to go down. So that first part is done. Second part, the exponential part, e to the 3x, you can see the 3x appear here as a match. So that means we need to multiply by an extra x here. So it is x e 3x, and we do not put a c in there, because d in there in this case, because it's already factored into ABC. So we don't need that. If you look at the third term, there's a sine cosine term, and as we discussed before, you don't need to add a, we need, because it's a sine, so we have to add sine cosine, but we don't need coefficient for both of them. We only need a coefficient for one of them, because it's already factored into ABC. So the first one you can say 1, and the second one you can say the next letter, so it is D, and you can say sine 2x. That is the correct form of those three terms. Now what we do, we can multiply them together, so you can bring x in front. So that means you can write this one as a x cubed plus b x squared plus cx, and then write just the exponential term e to the 3x, and then write the cosine and sine terms, the cosine 2x plus d sine 2x, and you can see that we only need 4 unknown here, 1 2 3 and a 4. So only 4 unknown. So you can see that you only need 4 unknown for this problem. Okay, so let's look at the next one. What if instead of a product, now you have a sum here? So if you have a sum, and you can see it is different now, because you have to write the form for each one separately. So in this case, you can see that you will have different, like more unknown. So it's the same yc. So the yp now is going to be, because the polynomial term, you get a x squared plus bx plus c. So that's the polynomial part. And for the exponential part, and you can see it's a 3x is appear here, is a repetition. I mean, you multiply by extra x, and not only that, you also need a constant here. So it's a dx e to the 3x. So that's what happened here, because there's no product here to carry these coefficients. So in the extra d here, and then the same thing, you can see sine 2x going to give you two more variables. So it's going to be e cosine 2x plus f sine 2x, and you can see that we have so many unknown here. So we have 1 2 3 4 and 5 6 unknown in this case, if you have a sum instead of a product. So you see the difference between the two now. Okay, so let's look at the next one. So let's look at several higher order differential equations now. So we have third order differential equation. So again, it's the same argument, same technique. So we're going to look at the characteristic equation first. So it is going to be lambda cube plus 3 lambda equal to 0. So that's going to give you, you can see lambda you can factor out. So you get lambda squared plus 3 equals 0. And then the zeros are, so you can see lambda equals 0 is from the first one, or the other ones are lambda squared equal negative 3. So that means lambda equal plus or minus square root 3i. That's a complex situation. So that means your solution, so you can write yc now. So yc takes this form. So let's use the t as the variable. So this is the yc, and then you can simplify this a little bit. So you can see this is going to be simply c1 plus. Now you can see that this is the same repetition situation. So c1 means a constant, and then 7 is a constant. So that means you cannot just write a constant for this one. So you have to multiply by an extra t in this case. So that means in this case the correct yp is going to be a times t. So you have to multiply by an extra t term, extra independent variable, to get the linearly independent term. So that's a right form for this one, right form of yp. So let's look at the next one. Suppose we have y triple prime plus 3y double prime equals 7. So we have an extra derivative term, double prime. So steps are the same. So we write the characteristic equation, so which is going to be lambda cube plus 3 lambda squared, and you can see lambda squared is common, so you get lambda squared lambda plus 3. So you set this one equal to 0, and so you get the lambdas are 0, 0, repeat, and then negative 3. So that means your yc now take the form, because of the repetition, is c1 plus c2, let's say the t is the variable, so c2t term, because of the repetition, because of these two zeros. And then we have, because of negative, so you can see 3e to the negative 3t. So that's the correct yz. So that means because of the repetition, and you need to go to the next level. So we already have a c1, we already have a c2t, so that we have to go to the next level. So that means the correct yp in this case should be, it is you can say a, you can say t squared, because it cannot be a constant, it cannot be just a t, it will be t squared term. So that's where the t squared comes into this. Okay, so it's a at squared is the correct yp for this problem. So let's look at two more little difficult problems. So how about this one? So we have this different looking problem now. Y double prime plus y prime minus 2 equals 0. So this is not a mistake, and there's no y term here. So what we can do, we can move that 2 to the other side. So we can write this one as y double prime plus y prime equal 2. So this is like similar to one of the previous problems now. So you can see, you can look at the characteristic equation as before, so which is lambda squared plus lambda, which is lambda plus 1 equals 0. So this is going to give you lambda equals 0 and negative 1. Those are the two values. So that means the your yc is, or this you can write as this. And again, because of the constant term, and we have a constant, you have to multiply by an extra x to get the correct yp. So correct yp would be a x, because you can just have a constant there. Okay, so let's look at just one more problem. So let's say we have like a little higher order differential equation. We have y to the fourth derivative equal 3 plus t. So t is the independent variable. So again, you can have the characteristic equation, which is lambda 4 just equal to 0. That's what we have. So that means the lambda repeat 0 repeat 4 times. So 0. So 1, 2, 3, and 4. So that means your yc now takes the form. So we have 4 terms now because of the 4 zeros. And then because of that, now what we want to, we write the polynomial and see we have t cubed term. So that means we can have any of those terms in the yp. So that means the correct yp now should be, so because the linear term, we have the at plus b term, because the linear term, and then we need to get a linear independent term, we need to multiply by t to the fourth power to get a That's the next term. You get the next term. So it's 3, so it's going to be 4. And that's the correct yp. So if you distribute, you get a t to the 4th power, 5th power, plus b t to the 4th power as the correct yp for this problem. I would like to give you 2 challenging problems for you to try. So now you know like how you to write these forms. So why don't you try to get the answers for these 2, and then you can put the answer in the comment section below. So let's try these 2. So the math challenge, write yp4. So we have y triple prime plus 3y prime equal 5t plus e to the 3t times sine square root 3t. And the next one, so we have y to the triple prime plus 3y double prime. So there's a y double prime term here. And then we have extra 4, and then also this is negative 3t now, not positive 3t. Okay, see whether you can answer these 2 questions now, and you can put the answer in the comment section below. So I hope you learned something. So thank you for watching.